Hello viewers, in today's class we are going to discuss one important problem from definite integrals, right? And here we have to evaluate this integral which is from minus pi by 2 to pi by 2, and the integrand is e raised to 2 times mod of sine x, then we have cos x divided by 1 plus e raised to tan x, right? So here we see that the lower limit is minus pi by 2 and the upper limit is pi by 2, and the mod function is also involved in this integrand, right? So here we'll see how, by making use of the properties of definite integrals, we can solve this problem, right? So let us start. So let us call this integral as I, right? So the first step is to make use of the method of substitution. So let us first substitute x is equal to minus y, right? So here we'll introduce a new variable y. So we'll substitute here x is equal to minus y. Now if we differentiate both sides, then we'll get dx is equal to minus dy, and since the limits vary from minus pi by 2 to pi by 2, so we'll also change the limits because we are changing the variable, right? So when x is minus pi by 2, then y can be obtained by taking x is equal to minus pi by 2 in this equation, right? So we have minus pi by 2, here we have minus y, so we'll get y is equal to pi by 2, right? And when x is pi by 2, then we have pi by 2 is equal to minus y, right? So from here we'll get y is equal to minus pi by 2, right? So now let us rewrite this integral in terms of y. So now I can be written as, see here we have minus pi by 2. So when x is minus pi by 2, y is pi by 2. So here we have pi by 2, and when x is pi by 2, that is the upper limit, then y is minus pi by 2, right? And we can replace x by minus y wherever x occurs, and dx is replaced by minus dy. So we have 2, and here mod of sine of minus y, and then we have cos of minus x minus y, and then here in the denominator we have 1 plus e raised to 10 minus y, and for dx we can write minus dy, right? So now from trigonometry we know that tan of minus theta is equal to minus of tan theta, and cos of minus theta is simply cos of theta, and sine of minus theta is equal to minus sine theta, right? So now this integral becomes, now see here we have the negative dy, right? So we can take this negative sign outside the integral. So we have pi by 2 to minus pi by 2, and we have e raised to 2 times the sine of y, right? Because see, sine of minus y is minus of sine y, right? And minus sine y is in the mod sign, that is, it is mod function. So we have a mod of minus sine y is simply mod of sine y, right? See here we can also write mod of minus sine y as mod of minus 1 times sine y, and by the rules of modulus function we have mod of minus 1 times mod of sine y, and mod of minus 1 is plus 1, right? So we have here mod of sine y, that is simply mod of sine y, right? So here we have 2 times mod of sine y, and cos of minus y is simply cos of y, and here we have 1 plus e raised to minus tan y, and here we have dy, right? So now I is given by this integral, right? So here we'll make use of one important property of definite integrals. That is, if we have the integral from a to b, f of x dx, then if we interchange the limits, then we put a negative sign before the integral. So we have b to a and f of x dx, right? So here we have this negative sign, right? So to neutralize this negative sign, we can interchange the limits, right? So I is now equal to minus pi by 2 to pi by 2, and we have e raised to 2 mod of sine y. Here we have cos y, and then we have 1 plus 1 over e raised to tan x, right? Because tan of y, right? Okay, so we have 1 over e raised to tan y, and here we have dy. Now we can simplify this integral further. So we have minus pi by 2 to pi by 2, and we can take LCM here. So we have e raised to tan y, then e raised to 2 times mod of sine y, cos of y, and then here we have 1 plus e raised to tan y, right? And here we have dy. So what we have done here, we have multiplied this 1 by e raised to tan y, so that we can get 1 plus e raised to tan y. E raised to tan y goes to the numerator, right? So viewers, now we have this integral, right? So let us call this integral as integral 1, right? Which is the initial integral. Now see, here we can also apply one more property of definite integrals, right? And that property is called the dummy variable property. That is, if we have the integral from a to b, f of x dy, then dx, then we can write this integral as a to b f of y dy, right? So if we change the variable from x to y, or from y to t, then the value of this integral remains the same, right? So we can also write this integral as a to b f of t dt, right? So this property is called the dummy variable property. So this integral I can be now written in terms of x. If we replace y by x, then we get the integral from minus pi by 2 to pi by 2. We have e raised to tan x, then e raised to 2 times mod of sine y, and here we have cos of y. Then here we can take x, here also we can take x. Then in the denominator we have 1 plus e raised to tan x and dx, right? So what we have done here, we have replaced the variable y by x, right? Because there is no effect on this integral if we change the variable from y to x, right? So now let us call this integral as integral number 2, and now we'll add integral 1 and 2. So we'll get I plus I. Here we have the left hand side, that is I plus I. Then here we have minus pi by 2 to pi by 2. And now if we add these two integrals, we can see that this portion, that is this portion, is same in both the integrals, right? So what we will do, we'll take common this portion, that is e raised to 2 sine x, then we have cos x, and here we have 1 plus e raised to tan x, and then in the brackets we have 1 plus e raised to 10x, right? So here we have e raised to 10x, because this portion e raised to 2 times mod of sin x cos x divided by 1 plus e raised to 10x is common in both the integrals, right? So taking this part common, we have 1 plus e raised to 10x. So here we have 1 plus e raised to 10x. So this term and this term get cancelled. So here we have I plus I is 2i, and here we have minus pi by 2 to pi by 2, and we are left with e raised to 2 times mod of sine x and cos of x dx, right? So this term 1 plus e raised to 10x, 1 plus e raised to 10x, these two terms get cancelled. So viewers, now we have this integral, right? Now let us see the right hand part of this equation, that is this integral, and see here if we apply this property, that is from minus a to a f of x dx, then the property says that if we have an integral from minus a to a f of x dx, then this integral is 2 times the integral from 0 to a f of x dx, provided this f of x is an even function, right? So by even function, it implies that f of minus x should be equal to f of x, right? So now let us see this integral. Now here f of x is given by e raised to 2 times mod of sine x and cos x, right? So if we replace x by minus x, let us see whether this function is even or not. So if we replace x by minus x, we have f of minus x is equal to e raised to 2 times sine of minus x and cos of minus x, right? So we have seen earlier that mod of sine of minus x is minus of sine x. Here we have simply cos x, because cos of minus x is cos x, and mod of minus sine x is simply a mod of sine x, right? So we see that f of minus x is equal to f of x. So this function is an even function, right? So now this integral can be written as, here we have 2i, so this integral can be written as 2 times integral from 0 to pi by 2, because a is pi by 2, right? So we have 0 to pi by 2, and we have e raised to 2 times mod of sine x, and here we have cos of x dx, right? So now this 2 and this 2 get cancelled, so we are left with I, and we have 0 to pi by 2, and we have e raised to 2 times simply sine x, right? Because see, here we have mod of sine x, and mod of sine x is simply positive sine x when we are in the first quadrant, right? Or x belongs to the first quadrant, right? Because here the limits of integration are from 0 to pi by 2, and we are in the first quadrant. This is 0, this is pi by 2. So when we go from 0 to pi by 2, then the sine function is positive in the first quadrant. So mod of sine x can be written as positive sine x by the definition of mod function, right? So now we have I is equal to 0 to pi by 2 e raised to 2 sine x cos x dx. So let us solve this integral by substitution method. So let us take u is equal to sine x, right? So when we take u is equal to sine x, du over dx is cos x. So we have du is equal to cos x dx, right? So for this part we can write du, right? Okay, and for sin x we can write u, and let us change the limits. So when we have x is equal to 0, then the value of u is sine 0, that is equal to 0, right? And when x is pi by 2, then the value of u is sine pi by 2, right? Sine pi by 2 is 1. So now this integral takes the form that is 0 to 1, because when x is 0, u is 0. When x is pi by 2, u is 1. So we have 0 to 1 e raised to 2u, and for cos x dx, we have du, right? So now we have a simple integral. So the value of this integral is e raised to 2u over 2, right? Because we know that integral of e raised to mx dx is equal to e raised to mx divided by m, right? Okay, so the limits are from 0 to 1, right? So let us take half outside. So we have e raised to 2u, 0 to 1. Let us substitute the limits and we'll take the difference. So we have half. E raised to 2 times 1 is 2, and e raised to 2 times 0 is 0, right? And e raised to 0 is 1. So we have e square minus 1 over 2, right? So viewers, the value of this integral is equal to e square minus 1 over 2.